that are very strong really need a lot of energy to pull them apart. Magnets that are not that strong, they come apart easily. Okay, so some particles are like really strong magnets, and you have to put in a lot of energy before you can break them apart. Okay, that is why I can heat up a pot. The pot stays a solid, but at the same temperature, the water in the pot is boiling. Okay, so let's have a look what happens going further. So now at some or other temperature, and this depends on every single substance, we are not going to see an increase in temperature anymore. Okay? At some or other temperature, the temperature is going to go, oh, wait, it's not increasing anymore. It's not increasing anymore. And that is the point where the solid becomes a liquid. Okay. Guys, I see a lot of you are very confused. We are talking about physical change of substances. All right? Those of you who are very confused, my question is, did you guys do heating and cooling curves in term 1? Some people have already said no. Okay, Matthew says no. Not in depth, fair enough. Okay. Sure, guys, this is a very hard topic for me to try and teach because normally I have my kids standing next to each other and then vibrating, moving, and the faster they move, the more space they take up. So that's quite easy to actually show. It's quite hard to explain. Okay. Sure. Okay. Right. I have a suggestion. I'm not going to completely deviate from my lesson, but what I am going to do for you, Sandra, you hit the nail on the board, okay? I am going to draw it today, and then Erin, you hit the second nail on the board, right? I am going to find you an animation that can show you how this works. Okay. Right. Some people are going, look, I understand this. The only thing that we're doing today is we're looking at physical change, okay, and how the particles move faster and faster. And then we need to start looking at chemical change. Okay, so let me go over to the whiteboard, and now, of course, I don't have one up. Okay, Miss P, the question. Okay, while the whiteboard is starting, I can answer Miss P's question. Okay, when you put toast bread in a toaster, all right, what you end up doing is you end up heating the starch and the glucose in the bread, all right, and almost like what happens in your cells with respiration, all right, is the starch and glucose turn into carbon. Sorry, guys, I need my special righty-paddy thingy. You know, the one that makes you guys think I can write on a mouse. And now, of course, my laptop's picking it up, so it's going to shout a little bit. Don't panic. Go. I'm very lucky. My husband does multimedia editing, and video production and animations and all sorts of things. So we have quite cool tools lying around at the house. Okay, right. I am going to use water as an example, okay, to try and show you, okay, the best I can with a picture what happens, all right, when we heat solid up. Okay, so jump in. There we go. Okay, so here is my water molecule. When this is a block of ice, the next water molecule is packed in there. It's going to look like a very funny, long, I don't know. Next molecule in there. The next molecule in there. Okay. And so forth and so forth. Oh, slide. Sorry, guys. Yo, thank you for getting me there. Better. New share. Whiteboard. Share. There we go. Okay. So hang on, I can start from scratch. It's not a problem. Sure. Come on. Here comes. Right. So I have got water molecules. Okay. So there's my oxygen. There's my hydrogen. There's my other hydrogen. Now, when I have ice, the water molecules pack together pretty closely. Guys, please don't think that this is exactly what they look like. They have this really weird shape, okay? Which I'm not really good at drawing. Art's not my strong suit. Okay, so I have all of these water molecules packed together. The lower the temperature is, the less these guys move, okay? So low temp means no movement. They just vibrate, okay? Think about someone who's in Antarctica, okay, and he doesn't have the right clothes on, okay? He's just standing there going, oh my goodness, I'm cold, okay? He just vibrates on the spot. So that is what these, Amani, I will try and explain that one to you tomorrow, okay? There's a very difficult explanation for that. Okay, so these little molecules only vibrate, okay? Now, I now come and I put energy in, all right? So what ends up happening, because I'm putting energy in, is I am making these molecules move faster. And now the problem is that this molecule, as it starts moving faster and faster, can't be stuck to that molecule. So when I put more energy in, so when I heat up the system, what ends up happening is the molecule still has an oxygen and a hydrogen. But now because it's moving more, this molecule, that one there, can't be stuck right on it. It needs to give it some space. And the next molecule needs to give them some space. And the next molecule needs to give them some space. And that happens with all of these molecules. They can't be close, 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 right? Because they need more space, because now they have a higher, not a high, a higher temperature. So they have more movement. Okay. Mbali, the energy is being absorbed by the molecules. So I'm putting heat energy in, and the heat energy is being absorbed by the molecules and being turned effectively into kinetic energy for these molecules. All right, so this is what happens when I go from a solid to a liquid. Okay? Molecules don't have personal space. They just have space that they need to be in to move. Okay? It's a little bit like you guys running around. If I make you run really fast, there's no ways you can run really fast as a group. Okay? You need more space. All right. So, when these molecules are really close together, there's this little magnet between all of them. Like there's a magnet over there, and a magnet over there, and a magnet over there. Okay? And these magnets between the molecules are very close together, and they pull them really strongly together. All right? Now, the further these molecules are from each other, the less this magnet can act on each other. Okay, and don't think that they're further apart because the magnet is less strong. The magnet is less strong because they are further apart. Okay, now we've put some energy in, we've made them move more. So now they're further apart and they've become a liquid. All right. Now they keep on moving faster and faster and faster and faster and faster. And then we reach a point where they move so fast. Okay. Miss P, I promise I will answer you. Okay. They move so fast that they can't be anywhere close to each other. Okay. So now we have fast movement. And because they are moving so fast, they're crashing into each other and they're pushing each other away. All right. Mbali particles are always moving, always. Okay, unless you can get them to like minus 273 degrees Celsius, then they might stand still. Okay, so these guys are moving so fast that they're gashing against each other, and I had a good answer there. This is now a gas. All right, this is what I mean by particles taking up more space, particles moving faster, needing more space, okay? And phase changes happening. All right. See, it wasn't that bad. Callum, we work with 3 states when we work in chemistry. Okay, we don't work with more than that. Okay, there are more plasma. I know there are more, but like really for like normal chemistry and physics, we use. Okay. All right. So, guys. This is what ends up happening when I put energy in. All right. Guys, you're asking questions here that is not quite covered by the syllabus. Now, I'm not saying I didn't do it when I was at university, okay? But it means I haven't done it for a very long time, okay? So all of these questions that are coming up here, the supercritical and the plasma and all of that, okay? It's not that I don't know it, and I'm glad we will answer your questions, but I need to go and double check my facts. Okay, ma'am, is this the reason behind steam's high kinetic energy because of the high movement of the molecule? Exactly. Okay, good job. All right, these molecules are moving really fast, and so when they hit your body, you tend to burn. Okay, all right. The temperature at which vapor pressure is equal to atmospheric pressure in a closed system. Yes, dude, that is the definition of boiling point, but only for metric. Okay, guys, so this is what happens. Right, now, I just want to take you back to those of you saying to me, ma'am, we never did the heating and the cooling curves. Okay, because there's something weird that happens at these points. Okay? Yes, I know, 6 minutes. Well, more than 6 minutes. Okay? So, this solid can be vibrating at quite a low temperature. Let's use water. Okay? So, I can have ice at like minus 11 degrees. Okay? I put energy in. It's still ice. Okay? All the way until 0 degrees Celsius. Okay, so however cold I can get my fridge, my freezer, that's how cold my ice will be. And I put energy in, and now the temperature of the ice increases. But it's still ice. Okay, it's still ice. Now I can keep on putting energy in. It's still going to be 0 degrees. I can keep on putting energy in. It's still going to be 0 degrees. Adding energy equals adding heat. Yes, Sandra. Okay. Now, when this substance changes from a solid to a liquid, okay, all of the particles need to be in far enough apart first. Okay, then the temperature will increase from, why did I put that first? Let's try that again. Then the temperature will increase from 0 degrees. Okay, so while it's turning from a solid into a liquid, the temperature you measure is 0 degrees Celsius. Now I've got this liquid and I heat it up. And now this temperature will increase. Okay? Does it mean EK is increasing too? It does mean EK is still increasing. Okay? So the temperature of the liquid will increase. We got it here at 50 degrees. I'm putting energy in, I'm putting energy in, I'm putting energy in. It carries on going until it gets to 100 degrees. Guys, don't know why I wanted degrees to go first, but apparently I do. Okay. Now, when the liquid gets to 100 degrees, the liquid is moving so fast that it needs to become a gas. So the liquid won't have a temperature above 100 degrees, okay, until all the liquid particles have turned into gas particles. And then, if it was possible for us to measure the temperature of the gas, then I could increase the temperature of the gas to, I don't know, 200 degrees Celsius. Okay. That is why we talk about a boiling point and a melting point. Because for each substance, all of this happens at a specific temperature. Okay. So, water, H2O, has a melting point of 0 degrees and a boiling point of 100 degrees. Okay. Butane. Okay. Butane is the gas, butane and propane is the gas that we use when we cook, right? Butane has a boiling point, so it becomes a gas at minus 30 degrees Celsius. Petrol has got a boiling point of, I think, round about 50 or 60 degrees Celsius. Okay, so each thing has its own boiling and melting temperature. State of water in room temperature is a liquid. Ethanol is a liquid. Okay, guys, all of these things you don't have to know off the top of your head. Okay, if you're interested in them, you can go and Google them. All right, cool. So this is states. Right. Back to PowerPoint. Okay. So we've spoken about the particles changing into a liquid, and then the exact same thing happens when it goes from a liquid to a gas. Water is H2O, guys. I don't know what HO2 is. I don't even think it can form. Okay. All right. Cool. That is literally everything that we just drew. All right. Now, I'm not going to go and carry on with the chemical changes. Tomorrow, I will show you a quick video, okay? Quick, just so that you can see this in an actual thing. And now I'm going to go and get to Miss P's question because she's jumping up and down. I can flip and see it. Okay? All right? Matthew, I can't throw something at you. Then what am I going to do? Like throw it at my computer? Okay. All right. So, Miss P, when I put bread into a toaster, the heat that I put in, right, causes a chemical change. It causes the bonds of the starch and the glucose to break and form new bonds. Okay, please go back a slide, Sandra. Cool. Right? So I end up taking the glucose and the starch and breaking it up, and I end up creating carbon. All right. So it is a chemical change, right? The color change that's normally quite a big indicator, all right? If I have a color change, that I've had a chemical reaction. Intermolecular forces, weak or strong? We don't worry about intermolecular forces when we make a chemical change. Okay. All right. Ma'am, how does pressure relate to different states of matter? It only makes a difference when we are dealing with gases and liquids. Okay, because solids don't take up the space of the container. If there's a color change, there's a chemical change. Let me quickly. There are the 4 things that generally tell you that there has been a chemical change. So a color change, or if you have gas forming, or if you suddenly have a solid forming, or if you magically just have a container and suddenly the temperature of this thing changes. Okay, so Miss P, this is simply, Miss P, are you asking me or are you asking the other random question? Okay, ma'am, will these slides be available on Google Drive? Yes, okay. We are working on getting this week's stuff up. Last week's stuff is on. Sandra, yeah, that's all that's physical changes, okay? Physical changes is about state changes, the physical states of matter and how we add energy. So tomorrow I'll start with a little revision, okay, that little video so that you can see the, which I can't draw, okay? And then we're going to go into chemical changes, okay? Callum, I'm pretty sure I can find a pretty decent animation. Okay, intramolecular forces. Intramolecular forces are forces between atoms, okay? We don't really talk about intramolecular forces. We talk about bonding. And then we also refer to intermolecular forces. Intermolecular forces being the forces between molecules. All right, guys, so africateengeeks.co.za, go to Lockdown eSchool, go find the resources. Otherwise, you can go to my Facebook page, go find the Lockdown eSchool group, and the resources are in there. All right, guys, I'll see you tomorrow for a little animation of stuff that I can't draw. Oh, someone asked, please can you explain where we can find the slides? Okay, just a quick screen share, a really quick one. Okay. Maths is after this, Mbali. Okay, quick screen share. For those of you who don't know, the rest of you can take 15 minutes, get out, clear your brains, and get ready for maths. I'll see you again tomorrow for chemical change. Okay, so you go to africateengeeks.co.za. You click on Lockdown eSchool, and then you scroll down. Okay, you scroll down until you find the Lockdown eSchool notes. Once you have that, you go find the grade 10 documents. You click on that and it opens a Google Drive that looks like this. And here you can find all the grade 10 notes for all the subjects. All right, guys, thank you so much for joining. It's so cool getting to know you and seeing you, okay? Good luck with maths, and I will see you again tomorrow. Bye.